The US Air Force has a history of researching and deploying directed energy weapons. This is a technology where high-powered lasers are used to destroy or disable enemy targets. Tracing their roots back to the 1970s, tactical ultra-short pulsed lasers, USPL, have been this cutting-edge technology that had been under development for several decades. And just recently, the US Air Force has admitted to creating a sophisticated laser so powerful that it can vaporize pretty much everything in its path. Governments all around the world have shown concern about the use of this technology. But why? Join us as we unlock the secrets of the US Air Force's high-powered lasers and how they could change the future of warfare forever. Even though development of the ultra-short pulsed lasers has been ongoing since the early 70s, the US Air Force have just recently turned this technology into a highly versatile weapon system that can be adapted to fit many different military vehicles and equipment. The USPL system uses ultra-short, incredibly high-powered laser pulses. These short bursts of energy have such a unique ability to cut, weld, and melt materials that they can slice through metals, shatter glasses, and even destroy electronic systems in a flash without even causing heat damage to the surrounding area, which makes it perfect for a variety of military applications, such as recognizing targets, determining their range, and disabling or demolishing enemy hardware. When this laser is fired, its energy is quickly absorbed by any material it is aimed at, causing it to heat up and expand almost instantaneously. In terms of numbers, this laser dishes out a whopping trillion watts for just 1/4 of a second. Although the statistics may be difficult to comprehend, the entire system is able to fit into a single compact device, allowing extreme mobility combined with devastating power. For reference, the intensity of these beams can be as much as 1 million times greater than the sun. But the ultra-short pulsed laser is not only a destructive device, it can also be used for non-lethal applications, such as precisely disabling electronic systems or temporarily blinding enemies. While it is still in the prototype phase, this laser is likely to be a game-changer for multiple sectors, even outside of the military, and is set to be deployed and used on the field very soon. Compared to other laser beams such as the kilowatt-class continuous wave laser beams, which become more weak and dispersed as they pass through the atmosphere, the far more intense USPL beam breaks down molecules and ionizes nitrogen and oxygen atoms. This creates a plasma channel, a sort of tunnel that keeps the beam focused and effective over a longer range. It achieves this by emitting extremely short bursts of light. These bursts last for only a couple of femtoseconds. To give you an idea of how fast that is, consider that a single burst from a femtosecond laser is about 1/1000th of the duration of a typical eye blink, but there is a reason for such short pulses. When any other laser hits a hard material, it vaporizes into a plasma, forming a sort of protective plasma cloud in front of the target. This can hinder further damage against it. But the USPL system manages to fire off pulses at such fast rates that they can hit fast-moving targets before the shield is even formed. Another useful side effect of this pulsing is a phenomenon called electromagnetic shock that can cause physical damage to a target's electronic systems, or even cause them to explode. This revolutionary laser technology also utilizes the power of specialized high-strength fibers made from specially coated materials that amplify light as it travels through them. This results in beams that are not only incredibly powerful, but also fast, able to travel at lightning speeds of up to 300,000 kilometers per second, making it nearly impossible to evade. This level of power and precision greatly enhances the laser's ability to deliver devastating strikes. But how exactly is this ultra-powerful beam produced? It works by creating a group of excited atoms or molecules which emit light in a specific direction at a specific wavelength. It has 3 core components: a light amplifying medium that is called the gain medium, a resonator, which is a reflective housing that contains the gain medium and bounces the light back and forth through the gain medium, and a pumping source, which is used to excite the atoms or molecules in the gain medium to a higher energy level. When the pumping source is activated, it causes some of the atoms or molecules in the gain medium to become excited and move into a higher energy level, emitting light. This light is reflected back and forth through the gain medium, amplifying it, creating a concentrated beam of light, This beam of light is then passed through a series of mirrors and lenses which shape and focus the laser beam into a concentrated ultra-short pulse of extreme electromagnetic energy. What is very unique about this system is that it has the ability to precisely control the pulse length and intensity, offering a huge variety of uses for the beam, turning this into a sort of Swiss Army knife of high-power weaponry. And high power is putting it lightly, as this is energy in the order of petawatts. In terms of natural phenomena, this is only comparable to events like solar flares and gamma-ray bursts. This amount of energy also gives it practical uses outside the scope of military applications. Its interaction with matter is beyond what can be achieved with traditional optical lasers, enabling the creation of high-energy photons and generation of plasma. This fine-tuning ability allows the beam to adapt to the absorption spectrum of the target and can even compensate for atmospheric distortions, ensuring that maximum power is delivered to its target. According to leading military experts, it is the USPL's different beam configurations that make it a weapon of choice. This includes a multiple beam configuration along with a sweep mode. The sweep mode allows the laser to rapidly scan an area and identify threats in a matter of seconds, while the multiple beam configuration allows it to generate multiple laser beams at once, making it possible to target several targets all at once. This makes it a game-changer in high-intensity situations where there are many enemies present, as it allows the US Air Force to efficiently and swiftly eliminate threats with surgical precision. However, as with any high-energy prototype weapon system, this weapon generates a ton of heat. To combat this, the tactical ultra-short pulse laser is equipped with robust and advanced cooling systems, including a combination of air and liquid cooling technologies. The cooling system adjusts its level based on the amount of heat generated, allowing for maximum efficiency and energy conservation. The entire device is composed of several control systems, including the laser energy control system, which regulates the amount of energy transmitted through the laser and monitors its temperature, while the beam quality control system maintains the stability and focus of the laser beam, making adjustments as necessary. The beam pointing control system ensures the laser is pointing in the desired direction using sensors and algorithms for constant tracking and adjustments. Together, these control systems allow the USPL to deliver a highly focused, stable beam of energy with incredible accuracy. This powerful and efficient weapon system requires minimal maintenance, while at the same time offers a long lifespan, something that is extremely important for long military operations where reliability is key and support is scarce. A true tide-turner, it will soon become a key part of the US Air Force's arsenal and is definitely technology that we should keep an eye out for.